Everybody, it's Tyler checking in at the Chicago Robotics Invitational with team number 10100, Phoenix Force. This is your winning alliance captain from the state of Wisconsin in Middleton. And we're going to be checking out this really cool robot here, talking about all the different mechanisms that go into it. And to help us talk about it more, I do have Abby, Thomas, Moira, and Ariana. And I can't wait to show off what goes into this winning robot here, what really makes it happen, all here coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. Hey FTC fans, are you ready for Freight Frenzy? Join us after kickoff live all weekend, September 18th and 19th, as we'll be out at Kettering University for the Bulldogs Robot in 30 Hours at youtube.com/first updates now. You'll get detailed breakdowns of game elements, the field, and prototyping and testing of robot components and assemblies. Watch live, view short videos after, and ask questions for the Kettering team at youtube.com/first updates now.
So Abby, starting off on this robot here, we're going to talk about your intake and that ring journey. So talk to me about kind of some of the design process, thought process as it goes all the way up into the shooter.
Okay, so starting off, we have Frodo 2.0 because with Frodo 1.0, we had an intake mechanism that was designed like an elevator where it would go up, and it wasn't just fast enough. So we decided to reiterate our design and do this current design for Frodo 2.0. And so what we hear is we have these wheels that also go back and forth and side to side so that we can pick up the rings from any angle. And then it goes into here, and we have these blockers to make sure that it is in alignment. And then we have our sensor here, which is a light. And so that can tell us how many rings we have.
Sure. And
to make sure that we don't have too many. And so we use these noodle arms in a chain system that pulls up the rings into this, and so it's shaped like this to make sure that the ring goes in smoothly. And then we have here designed a servo system that allows it to grip the ring so that it can pull it into the basket here. And so this servo allows us to kick the ring whenever we want to, and then this makes sure that the stack stays in place when we shoot it out through this system here. And so this wheel pushes it through and then allows us to shoot it through.
Well, let's unpack this a little bit and see. Yeah, let's see a couple of rings come through. I'm really interested to get a nice close-up on that process right there. It's almost like a popcorn machine going in.
Yes.
So really neat on there. And then for your shooter, talk to me a little about some of the thought process on, like, do you know like how much compression got put into it, or how did you determine like what the spacing is going to look like as a ring comes out of your machine?
We just kind of measured the widest part of the ring, and then we kind of just designed our, we 3D printed this to fit the size of the ring. And
Sure.
Then we also put tape, if it doesn't have enough pressure in there, to press it up against the wheel so that it can shoot out smoothly.
Well, Thomas is going to talk to us about the wobble goal mechanism next, which is on this other side here. Can we rotate the robot just around a little bit and we check that out? Very cool. So very wide intake for this. Might be one of the biggest wingspans I've seen amongst a wobble goal mechanism, but tell me a little bit more about everything that goes into this.
All right, so as you said, yes, it's very wide, so we got a really wide range of picking the wobble goals up, because sometimes just going a little bit too fast around, so it gives us a little bit of that extra speed for that. Right here is a locking mechanism to make sure it does not get knocked out when we're driving super fast, because this robot is pretty quick around the field. It uses two servos down here at the bottom, and they work in sync here. It's on a joint cable with one reversed here. And yeah, it's very quick, and then we have a lifter that maybe brings it up so we can drop it over the side of the field.
One thing I asked, from a complexity side, this seems to be one of the more complexly made type wobble goal mechanisms I've seen. When you were kind of looking at the game challenge, you know, like what made you want to stray away from, like we've seen some teams that it's literally just an arm that flops or something like that. What made you want to go with something more like this?
Well, as I said, this is actually our first iteration. I actually didn't say that. This is our first version of it, I believe. We originally had it actually on the back of the robot.
Sure.
But then when we had this extra, we had changed this back here to have the bucket back there. We moved it to the side here. which honestly, I prefer as the driver. Makes it a lot quicker for picking them up from the side and just turning 190 degrees to drop it off. But we just stuck with the design because we think it just worked pretty well. So why change what's not broken?
Fair enough on that. Moira, you're going to be talking a little about, I'm actually curious to see in here, it's this little claw, this tiny little claw that's on this side that we'll spin around here and take a look at. So talk to me about that, and then we're going to talk about some of the aesthetics of your robot, including your LEDs.
Absolutely. So our claw is actually, this is not a first for our robot. We had the exact same, or a version of this claw on our robot last year that we used for the challenge to try to get over the line in the mid-goal to get those extra points. And we use that same ideology, essentially, to put on the claw on this robot to kind of get over the line, get those extra points without having to take the time to move the robot. Last year, we actually used this as a little bit of a personality piece for our robot as well.
Okay.
And it kind of gives him like, hey, hi, how you doing? I'm right here. It was a 3-piece arm, but it's essentially the same thing here. It gives us a little extra reach, a little extra mobility without having to move our whole robot.
Sure.
It's quick, it's a servo, so it's really it's a really simple mechanism.
Well, 10100 Phoenix Force, thanks for taking time to speak to us about your robot. Good luck to you here at CRI, and look forward to seeing you at future competitions. Thanks for taking the time. We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.